I am Jesus Maria Munarriz, PhD in Industrial Engineering. I have devoted part of my time to the study of current physical theories, especially the theory of relativity. Several books have been published as a result of such studies, from which I have gotten the idea that a physical reality exists that is different from the reality that is usually interpreted. For instance, in 1992, I published my book Conjetura 21, claiming that the expansion of the universe was flat and formed a huge disk that spun around an axis perpendicular to the plane of the universe, when the current model depicted the universe located on the surface of a sphere. 8 years later, Professor De Bernardis, with a team of 36 associates from various universities and research centers, reached the same conclusion. During this time, I have also designed several scientific instruments, including a horizontal gravimeter, the theory of relativity is quite difficult to be understood by the general public, except for the principle that no object may be observed at a speed higher than light, which has been universally accepted. To prove this principle wrong, I am going to propose an agreement to make language easier. I will call observable object the image of the actual object when this passed by any point in its path. When the actual object is close to the observer, both objects are perceived together. For instance, if I move my hand, even though the observable object is behind the actual object, the observer cannot tell one from the other, as the distance that light travels to inform us about the location of the actual object is too small, and therefore the observable and actual objects get confused, and despite the dissociation between them, the human eye is unable to tell them apart, right? And conversely, when the actual object is at, let us say, for instance, 1 million light years apart, the information of the observable object being at that point will take 1 million years to reach the observer. The actual object, however, will continue its path during such time, and we will have no even idea where this actual object is, right? In the figure, we see the observable object at point A, while the information about this location reaches the observer. The actual object has moved away. From the point A, the observable object will follow the same path of the actual object that will be farther away in an unknown location. At the same time, we discover that all the objects that we see in the universe are observable, and the only real point, the one occupied by the observer. And to make things even more complicated, the appearance of the observable universe is false because it is made up of various observable objects that, in due time, at different points in their history, belonged to the real universe. So we see a star at a distance of 1 million light years, located beside another star at 100 million light years. That is a false image, thus all observable objects are unreal. This situation notwithstanding, astrophysicists assume that all the data that we measure in the observable object are identical to the data of the actual object when it passed that point. So far, we have been able to see in the figure that the speed of the actual object was different and higher than the speed of the observable object, as both objects left the location of the observer together, and the location of the actual object is beyond the location of the observable object. Different velocities mean different energies and their reaction different from any type of attraction. And if we covered all the objects that we observe at an infinite speed, we would find that their places were empty. That is, no objects were there. The observable universe, again, is something unreal and exists in an image that is continuously substituted by another as a result of the time that light requires transferring information. If the speed of light were infinite, we would only see one real universe. The current situation is as if in a family picture, the grandfather appeared like a 2-year-old kid in the arms of his son at the age of 60, and the rest of the family members were depicted at random ages. The picture would be false. The same happens with the observable universe. Everything is false. From any other point, the observable universe will be different from the previous. There are as many observable universes as observers, but there is only one actual universe, invisible. The problem is, as I mentioned before, that the scientists think that all the data on the actual object directly inaccessible are in the observable object. That is, velocity, energy, mass, temperature, etc. are truthfully represented in the observable object. They forget this is no more than an image, since we are unable to access the actual objects with our measuring instruments. We logically search for data in the only thing that is related to them, the observable objects. However, observable objects can only show us the path followed by the corresponding actual object, and that is it. It is worth to review the experience of Saul Perlmutter, who in a very elaborate process managed to obtain the observable object of the SNE supernova at 2 different positions, separated by a brief time interval. This supernova is observed at some 7 million light years. This is approximately half the current life of the universe. Due to the difference in magnitude of the same observable object at the 2 positions, Perlmutter inferred that the velocity of the expansion had been extremely high. Therefore, Perlmutter concluded that the expansion of the universe was accelerated, and the acceleration could only result from the presence of a large amount of dark matter attracting the visible universe outwards. Well, this reasoning is petitio principii, because it takes the velocity of expansion of an observable object for the velocity of actual object that generates it. On the other hand, we know that under the principle of Hubble, more distant objects, that is to say the oldest, travel faster than closer objects, which are also more recent. Thus expansion is delayed over time, just the opposite of what Perlmutter claims, and I add, on my account, that in those locations where stable planetary systems exist, the expansion is over. With this introduction on actual and observable universes, I am proposing an example where the difference between the actual and observable velocities may be so big that justify Perlmutter's mistake, and at the same time proves that velocities may be observed in the observable object that are much higher than the speed of light. Let's imagine that an actual object moves towards the observatory at a speed slightly lower than the speed of light. When passing by point A, a signal will switch on. So, at that point, the observable object will be seen with the signal on. When the information reaches the observatory, the distance from point A to the observatory is 365 light days, and the actual object takes 366 days to cover it, and that is 1 day more than light. Now the image of the observable object with the signal on will reach the observatory in 365 days at the speed of light, and we will observe that its speed is extremely high, for it only needs 1 more day to travel from point A to the observatory, since it gets there with the actual object. The velocity of the actual object is 365 light days divided by the time, 366 days, while the velocity of the observable object is 365 light days divided by 1 day, that is to say 365 c, 365 times velocity c of light. There is still one more question to answer. Why do we prove that it is the observable object that exceeds the velocity of light instead of doing it with the actual object? The answer is the same as repeatedly stated above, because the observable objects are the only objects that we can measure and use to apply our theories. Actual objects are as if they did not exist. Nevertheless, there is a solid line of argument that proves the existence of actual velocities higher than the speed of light. Using Perlmutter's experiment, again, we can say that the observable velocity that he assesses may be infinitely higher than the speed of the actual object, which would invalidate his explanation of an accelerated expansion and dark matter magnitude. In brief, the dissociation, the effect that occurs between observable and actual objects, produces this result when we measure the speed of the observable object at a given point. It differs from the speed that the actual object really had when passing by such point.